This question asks that we identify the graph that best represents the relationship between the kinetic energy and the velocity of an object. To start, we should write the equation for kinetic energy, which is kinetic energy equals 1/2 times the mass of the object times the velocity of the object squared. Next, we should eliminate the answer choices that are wrong. Let's look at graph A. Graph A states that as velocity increases, kinetic energy must stay constant. This is wrong because velocity is inside the equation for kinetic energy, meaning that as velocity changes, kinetic energy must change as well. So we can eliminate graph A. Graph C states that as velocity increases, kinetic energy must decrease. This is wrong because kinetic energy and velocity have a directly proportional relationship, meaning as velocity increases, kinetic energy must increase as well. So we can eliminate graph C. This leaves graphs B and D. First, let's examine graph B. Graph B shows that kinetic energy and velocity must have a linear relationship, meaning that as velocity increases, kinetic energy must increase by a constant value. Allow me to illustrate why graph B is wrong. If, for example, we have a velocity of 1, making the kinetic energy equal 1, then we get a velocity of 2, kinetic energy will equal 4. This is because kinetic energy has velocity squared in it. Next, if we have a velocity of 3, then kinetic energy must equal 9, because 3 squared is 9. First, kinetic energy increases by 3, but then it increases by a different value of 5, making graph B incorrect. This leaves only one graph, and this is graph D, the correct answer.